Okay, so today we want to go ahead and start working on fraction concepts. So who can tell me what a fraction is? It's part of a whole. What do you mean by that? Give me an example. What about 1/3? 1/3 of a pie? That sounds good. What kind of pie? Apple? Oh, that's my favorite, especially with some French vanilla on top, huh? Right. So Zach's right. It's part of a whole, okay? Now, we use fractions in a lot of different applications as adults. Now, in this particular fraction, you notice that there's one number over a line and then a bottom number. The top number represents your part, and the bottom number represents your whole. What other kind of math element does this represent besides part of a whole? Division. Yeah, this can represent division. So a fraction is usually something less than 1. Because if I were to divide this, I would get a decimal, 0.6. So it's part of a whole. A whole would be the 1. We call the part the numerator and the bottom the denominator. So that's what the math terms are for the part and the whole. Numerator on top, denominator on the bottom. So you'll see that I have cherry pie there, but apple is my favorite, okay? So thinking of pie, thinking of pizza makes fractions a little bit easier for some reason. I don't know why, but it does. So let's talk about the different types of fractions. Now, what fraction, give me the part and the whole, does this little graph represent? If I do the blue, 3 out of 4, right? So we have 4 squares and 3 of them are blue. How many are red? So what would that fraction be? 1 out of 4, okay? Now we got some little kitty cats. Now, out of these kitty cats, how many of them are white? 1/2? How many cats are there? 5. Well, how many of them are white? Okay. Well, I counted this one as white because he only has a little brown right here. No, 1, 2, 3 white ones. He's mostly white, so I put him there. And then 5, okay? So there's 5 kitty cats there, and about 3 of them are white. One's got a little tan on it. Okay, so what fraction of these dresses are green? 1 out of what? I need a fraction. 1/10. Okay, now I've got a Hershey's chocolate bar here. Now I'm going to start eating some of it. Here's the little pieces. There's 12 of them. And I ate some. So can you tell me how much of it is missing? What does the question say? How much did you eat? Okay. 5 out of what? All right. Now, here's a nice little real-world problem that we're going to use fractions for. Because you guys say that you don't use your math, but yes, you do. You use it. Reggie has 4 quarters, 5 dimes, and 7 nickels. What fraction of his coins are dimes? 5 out of 16, somebody told me? So So first I need to know how many total coins he's got, which is 16. That's my whole, or my denominator. And how many of those were dimes? 5. So the people who said 5 over 16 are right. Okay? So total them up to figure out how much in total you have, or the whole, and then answer the question. Any questions about this one with the yum yum? Laura worked a 10-hour shift. She worked in emergency for 9 hours of her shift. What fraction of her shift did she not work in emergency? So what fraction though? 1 out of 10. So here's some key points so far. A fraction is an equal part of a whole. Numbers, shapes, and objects can be written as fractions because we just did that. We write fractions. Here's some examples. 1/2 is 1 over 2. 3/4 is 3 over 4. 5/8 is 5 over 8. Now, the next thing I want to talk about is how to write fractions. Do you think spelling counts when we write fractions in words? Of course, just like everything else, right? All right, now, this is what I want you to keep in mind. A fraction with a 4 as its denominator is read as fourths. Say the number of the numerator first and then the word fourths. For example, to read 3 over 4, we would say 3/4. For other fractions, the rule with the numerator stays the same, but the word for the denominator changes based on its number. Like for instance, 11 over 13, we would say 11/13. I want everybody to say that. 11/13. Okay, good. Now, here's a chart to help you. When your denominator is 2, you would say half. When the denominator is 3, you would say thirds. 4 is fourths. We already reviewed that. 5 is fifths. 6 is sixths. 7 is sevenths. 8 is eighths. 9 is ninths. And 10 is tenths. Notice how ninths is spelled? Yeah, we don't have an E there, right? Okay. So I want you and your table mates to write these fractions here in words and practice saying them. Take a few minutes to write these 8 fractions in words and then practice saying them. Give you guys a few minutes to do that. All right, so what's this first one? Say it out loud to me. 4/5. This is how you spell it.
So you don't put no hyphen in between?
No, it's not by tens. Okay, what about this one? Did you write 9/10? Okay. 7ths. 2/3. You know what? I would have put an S here. I forgot to put an S here. I would have put an S. 8/9. 1/2. And then 5/6. And no, you don't have to put a hyphen. Why do you guys think you need to put a hyphen? Nah, you don't need to have a hyphen in this case. You don't have to put a hyphen. Oh, okay. No, you don't have to put the hyphen. That kind of freaks me out if you have extra hyphen, but that's okay. I guess I'll take it either way since it's in your packet that way, but you don't really have to. Any questions on this little exercise? Did anybody spell anything wrong? Did you spell ninths right? Okay. I think that's the one that people spell wrong a lot. And then look at eighths. You got those two H's in there. Sometimes that freaks people out too. So don't be freaked. Okay? And then I think I should have an S here for 2/3. Like I said, I forgot to put an S there. So you guys put an S there. Right here on number 4. Put an S. No, thirds doesn't have a TH in it, honey. But you have to put an S there. Just put an S there, okay, Ellie? So reading and writing your fractions is very important. That's why we did this exercise. And you guys can do some more practice. I believe I gave you more of this kind of practice on page, I think it's page 6. Yeah, on page 6, okay? So you can do some more of this practice on page 6 in your packet. Okay, any other questions on this exercise? Nope? Okay. All right, now let's go to, and you can do more on page 6, like I said, okay? Now I want to talk about the 3 different types of fractions. The first type that I have here as an example for 1/2 is called a proper fraction. A proper fraction has a smaller numerator than denominator. An improper fraction, there's 2 different types of improper fractions. There's one where the numerator is larger than the denominator, or when both the numerator and the denominator are the same number. So why would this 9/9 be improper? Because it equals to 1. If I divide 9 into 9, I get 1 whole, but I've basically taken that whole and broken it into pieces, which we have to do sometimes in our math. So this is considered improper, and so is this one, where the top is larger than the bottom. So you have 2 instances where you can have an improper fraction, all right? So make note of that. Now, the last type of fraction is called a mixed number. And in a mixed number, what do I have here? I have a whole number and a fraction. So anytime you have a whole number and a fraction, that's called a mixed number. It's mixed. You've got a whole number with the fraction combined. Are there any questions on these 3 different types of fractions? Okay, let's see if you guys know it. So just tell me what type of fraction we have here. What's that? Improper fraction? That would be a proper fraction. Mixed number. Improper. Well, the way this looks now, it's proper, right? Okay. And what about this one? Improper. Okay. So you'll need to be able to identify the different types of fractions. And that starts, I think, on page 8 in your packet, okay? Got a couple of exercises there. So let's do a quick review of what we've learned so far. What are fractions? Part of a whole. The top number is called numerator. Bottom number is called denominator. What are the three types of fractions? Proper, improper, and mixed. Hey. Okay, so the next slice of the pie that we're going to study is how to use fractions. We use fractions all the time. Basic use of fractions. In many instances, fractions represent part of a whole. When you pay your monthly insurance bill, you're paying 1 month out of 12 months on your annual bill. Secondly, a fraction represents division. Fractions are written with the division symbol, as in 1/2, where 1 is divided by 2. Remember, the bottom always goes into the top when you're dividing. Please note that the denominator of the fraction should never be 0, since it doesn't make sense to group a number by 0. In math, 1 over 0 or any number over 0 is undefined because it makes no sense. Basically, you're saying, oh, I'm grouping in groups of zeros. Why would you do such a thing? There's not even 0, because it doesn't make sense. Why would you take the time to take $1 and then say you're going to group it into zeros? Doesn't make sense. It's not practical. Fractions are most commonly used in household or customary measurement. Measuring out the quantity of ingredients in a casserole to serve a family of 5 in cups, teaspoons, and tablespoons illustrates a use of fractions in measurements. What's another use of fractions in measurements besides recipes? Besides recipes, what else would you use fractions for in everyday life? Measuring. Yeah. What about medicines? So how many of you are parents? Okay, so if you're at home and you need to give your child some medication, what kind of unit would you measure that in? You could do ml. Do you guys have the ml syringes handy at home? Or teaspoons, okay? For babies, you always use the smaller spoon, little tiny teaspoons. Well, how many teaspoons are in a tablespoon? Oh my goodness. Come on, you guys. Yes, there's 3. If you don't have your special syringe for the milliliters to measure out, you need to know that there's 3 teaspoons in a tablespoon, okay? Because you might have to give your child some medicine with a spoon, with a teaspoon, okay? So don't forget that. Comparisons are easily represented in fractions. For example, there are more leather sofas compared to fabric sofas in a specialty furniture store. Boy, I sure would like to go get me a leather one. Those things last forever, don't they? You can take them from generation to generation to generation. I love those leather. Huh? Oh yeah, they're going to have to replace it if they mess it up. But, I mean, they last for hundreds of years, you know? Give me another comparison where we would compare, use fractions to compare in everyday life. So, like grocery shopping and doing what? Yeah, comparing your prices to your units. That's a comparison. We do that all the time. As adults, hey, you know, which one's cheaper? Uh-oh. But if you're talking about a leather couch to a fabric couch, it's okay to pay a little bit more. Just because that leather couch can last for a long, long time. Okay? miles per hour. How long is it going to take me to get there? You know?
And your gas, too.
Yeah? So what would a gas one be? What would that ratio? I call those ratios, those comparisons are ratios. If I were doing gasoline, what do we normally do for comparison? Price per gallon. What's wrong with you guys? Come on. Wake up now. That should be easy. Okay, so what I'm going to do now, you guys, I'm going to give you some examples. And you and your table mates figure out the use. Determine the use. Now let's review those real quick. I'm going to write them on the board. You guys tell me what they are. The first one was what? No, use of a fraction. Part of a whole. So you got to tell me what use is being illustrated for each of those problems. Remember, there's 4 uses. Then we said division. Then we said measurement. And then we said the last one was comparisons. So for each of those 6 situations, tell me, is that part of a whole? Is it division? Is it measurement? Or is it comparisons? How is the fraction being used? No, you guys go ahead and hook it up with your table mates, and then you're going to tell me, okay? So let me give you guys a few minutes to go through that, and then you guys have your answers ready to share. Okay, so let's go over these answers. I had measurement for number 1. What did you guys have? You could have said 4 ounces is part of 16 ounces, which is a pound, right? But what makes it measurement, though? Weight. Isn't weight a category of measure? Okay. What did you guys pick for number 2? I think it's a comparison. Isn't it a ratio? See this ratio, 3 to 1? In a recent survey, the dance class preferred 3 to 1. You're comparing. The key word here is compare. Okay? What about number 3? Now remember, all of these do represent part of a whole, but some of them are just strictly part of a whole, and some of them are measurement or comparisons or division. Okay? So what about number 3? What did you guys say for number 3? I said part of a whole as well. Okay, because he ate all that pizza. Okay, number 4, what did you say? Measurement. Okay? 1 foot deep of nasty garbage. Okay? Well, yeah, that's because you used to do that kind of, you were a sanitation worker, right? Yeah. So you're used to that. Did you guys have to put nose plugs or something, or you got used to the smell, or what? Oh my gosh, I don't think I could. I'd be barfing all along. Oh yeah, you guys get paid pretty good too, don't you? Yeah. As a sanitation worker, they get paid pretty good. I know. What about number 5? Division. And number 6? Part of a whole. Okay. And yeah, some of these you might have more than one answer. You might have that part of a whole. You're going to have a tendency to want to do part of the whole all the time anyway, just because that's what a fraction is. But there are some situations where it's more of a measurement and part of a whole. Okay? So you guys will have an opportunity to do more of this practice on exercise E, page 10. You've got 12 problems there. And all you're going to do is you're going to tell me whether it's part of a whole, division, measurement, or comparison, just like we did with our exercise here. Okay? And this is one where you're going to have to think about it. Okay? So you and your table mate, why don't you guys take a look at page 10, And see if you can do the first one or two of those. Write the number of hits to the total number of bats in a game. What would you put for number 1 there? You're talking about hits to the total bats. Why would you compare that? Well, I know that they do division to figure out your batting average, but I'm not asking for the batting average, am I? I want the number of hits to the total number of bats. That's part of a whole. But I understand why you're saying it's a ratio as well. It could be a ratio, yeah. Just put 1, yeah. I just put 1 for that one. And then what about number 2? Compare the number of apples to the number of oranges. That's definitely a comparison. What would you guys put for number 3? Determine the growth of an infant in inches. Measurement, yes. And then let's just do number 4 and you guys can do the rest. Tell the investor her share of the profits to the total profits. Division? Her share to the total. It's part of a whole. Why are you guys dividing that? If you divided that, they're not going to understand that. But if you wrote it as a percent, they might understand it, but that's not what we're doing. And number 5, what would you do? That's easy, right? Because it says divided. Okay, so you guys are going to finish that up. I'm going to move on to something else now. You'll finish this one up later, okay? I need everybody's attention because this is where people have troubles. Exactly. Now listen, if you don't know your multiplication tables and you don't know how to divide good, you're going to have problems. Now I will show you 2 different techniques for reducing. You pick whichever one you want, but I'm going to tell you, you're not going to have a calculator to do this. You're going to have to use your brain. You need to know your multiplication tables, okay? Now, equivalent fractions. Equivalent fractions, what equivalent means is that I have exactly the same size. Even though the numbers are different, I have exactly the same size. Now, in order for you to reduce numbers down and have the same size, you need to reduce both the numerator and denominator by the same factor, the same number, okay? Which means that you need to pick a factor that goes into both the top and the bottom evenly. Otherwise, you're not going to be able to reduce it. So in this example, I have the fraction 14 over 16. What number goes into both 14 and 16 evenly where there's nothing left over? 2. So I need to divide both of these by 2 in order to make an equivalent fraction that's reduced. So if I divide both by 2, what does my new fraction become, or my equivalent fraction? 7 over 8. When you are reducing fractions, you must reduce by the same factor, the same number, both top and bottom. Otherwise, you're not able to reduce. Remember, a factor is a number that divides evenly into another number. The factors of 15 are 1 times 15, 3 times 5. These 4 numbers go into 15 evenly where there's nothing left over. And this is kind of piggybacking on what we did yesterday with prime numbers and factors. A common factor is when 2 numbers have the same factor. It's called a common factor. Now, a common factor of 30 and 12 is 6, because 6 will go into 30 evenly and 6 will go into 12 evenly. List 2 more factors that 30 and 12 have in common. Give me another number that both goes in 2. 2 goes into 30 and 2 goes into 12 evenly. Okay, give me another one. No, 3. 3 goes into 30 evenly and 3 goes into 12 evenly. Okay? So those are common factors for 30 and 12. Now, what is this number? No, what is the number? What is this number? What's this number? What's this number? Okay. Now, I want everybody to say this with me. When the factor is 1, I am done.
Factor is 1, I am done.
A little louder.
When the factor is 1, I am done.
1, I'm done. You need to know when to stop. Now, I can't tell you how many times students have been reducing fractions and they keep going and going and going. And I go, why are you going? The only factor that goes into these two numbers is 1, so you cannot do any reducing. You need to know when to stop yourself. So, when it's 1, I'm done. I want to hear that.
When it's 1, I'm done.
When it's 1, I'm done.
When it's 1, I'm done.
Okay. So I have the fraction here, 7 over 8. Now you guys know 7 is prime. And what happens when I get a prime number? The only factor I'm going to have is 1 in the number. So the only number that's going to go with the other number is 1. So another big clue is when you have prime numbers, oh, you're probably done. Check and see. If you've got a prime number, you're probably done. Because remember, there's only 2 factors in a prime number. Yeah, because they come in handy. All right. Now, sometimes you guys are going to see this term. GCF is the abbreviation. And what that means is greatest common factor. That's the largest number that 2 other numbers have in common. Because remember, we did 30 and 12. And I told you, okay, 6 is a common factor. Well, 6 was the largest common factor. What's the largest common factor for 14 and 21? I've already written the factors for you. No. It has to be common in both. So 7 is the greatest common factor, right? So when you see GCF, that's an abbreviation for greatest common factor, you're going to... James, you're not listening. 21 does not go into 14, so you cannot use 21, okay? You have to use a number that goes into both the top and the bottom. It has to be the same number or they're not equivalent. So we talked about being equivalent because it's the same factor. And the largest one in this list is 7. Okay? It's 7. What about in this list? I already wrote it out. Greatest common factor, GCF. Is it 4? Okay. Oh, okay. So we have a question about greatest common factor and least common multiple, which we learned yesterday. Is that what you're talking about? Okay. What was it I told you to think about when you talk about multiples? What did I tell you about multiples? Oh my gosh, I can't believe we forgot in a matter of 24 hours. That's a really good question, Donasil. Least common multiple and greatest common factor. She says she gets confused with those. Okay, so everybody be writing this example down. All right, let's use 30 and 6 and 12. 30, 6, and 12. Okay. Yesterday, I taught you how to find the least common multiple. How do I find the least common multiple? Huh? Hey, hey, hey. And what do I do with the biggest number? Okay, have I gotten to the least common multiple yet? Hello? What is it? Goes into 60. 6 goes into 60. 12 goes into 60. My least common multiple will be 60. All I did was I got multiples. I took the largest number and multiplied it by the counting numbers. Remember we talked about that yesterday? And this is a shortcut to figuring it out. And then I compare. To all the digits. All right, now how am I going to figure out the least common factor? Well, here's the long way of doing it. And for this one, it's not going to be too bad. How do I get 30? 1 times what? 2 times what? 6? 3 times what? Yep. 3 times 10, 4 doesn't work, 5 times 12, right? No, 5 times 6. So here's the factor list for 30. Then for 12, I've got 1 times 12, 2 times 6, 3 times 4, and that'll be it. And for 6, I'm going to have 1 times 6 and 2 times 3. What's the greatest common factor for those 3 numbers? No, 30 doesn't go into 6. The largest one is 6. Your greatest common factor is 6. Your greatest common factor is the largest number that goes into all 3 numbers evenly. That's 6. Your least common multiple is the smallest possible number all 3 numbers go into. They're opposite one another, right? And that's 60. Largest number that divides into all numbers. Smallest number that all numbers go into. Is your least common multiple. And there's a big difference. We use this one for raising and reducing fractions, and we use this one to figure out what our least common denominator is going to be. Okay? So we need to know both things. We need to know both definitions. Does that help, Donasil, a little bit? Okay. That was a great question. He's thinking. Because Because he's like, okay, what is reducing? So which of these am I going to use for reducing? The LCM or the GCF? The GCF. Because if I use the largest common factor, I'll get to the reducing faster. But of course, I could use, like for these numbers, I could use 2. 2 is in both of them. I could use 3. 3 is in all 3 of them. But those aren't the largest. I'm going to have to divide again. If I were to reduce these numbers by 2, I would still have to reduce them again by 3. Because isn't 2 times 3, 6? I'd have to reduce again. So if I pick 6 initially, I can just do it one time and I'm done. But I don't want you guys worrying about that. I want you to reduce as soon as you can. If you just see that they're both even and 2 pops in your head, use 2. But if I ask for the greatest common factor, you need to tell me what that is. Okay, so let's do it. Let's put him out of his misery here. Reduce a fraction to lowest terms by finding a common factor that goes into the numerator and denominator evenly. So for our example with 30, 12, and 6, we could have used 2, we could have used 3, but 6 is the greatest common factor. Then divide the numerator and denominator by that common factor until you can reduce no longer. Keep doing it till you can't reduce anymore. And then how do I know that I'm done? I like God's little finger. 1. Okay? So what's the greatest common factor for 12 and 72? Hello? 12. Does 12 go into 72? How many times?
5 times.
We need to know our multiplication table.
6. 6 times 12 is 72.
So if you divided that by 6, what would you have left over, James? If you reduce this fraction by 6, what do you get for the new fraction? How much?
You get 1.
Oh my gosh.
You reduce it by 6, right? And you get 2.
Go ahead and reduce it by 6 and tell me what the new fraction is. That's all I ask.
1/3.
You
You get 2 6.
get 2 12ths. Can 2 12ths be reduced? By what? So 6 is not the greatest common factor. What number is? 12. Now, I just explained greatest common factor. You guys are really, really concerning me here. You insisted upon using 6, but 6 is not the greatest common factor. You can reduce it by 6, that's fine, but you're going to get 2 over 12. You got to go ahead and reduce it by 2 again. 6 times 2 is 12. So the greatest common factor really is 12. Come on now. Now, when I reduce it by 12, what do I get? 1 over 1 over 1 over. Because I was about to start screaming. No, you didn't. You were quiet. You were quiet after you. No, I didn't hear no 1 over 6. I said it's what? You got quiet. You might have been saying 6 in your head, but your mouth wasn't saying nothing. Okay, so let's review. Okay, it's okay for you to use 6 here, but when you got 2 over 12, you would have to reduce it again by 2. 2 times 6 is 12. 12 is the greatest common factor for these two numbers. So if you do 12 initially, you only have to reduce 1 time. But if you pick 6, it's okay me. Go ahead and reduce it by 6 and then see that you have to reduce it again, okay? Yeah, whatever will work is fine. It's just that if you are asked on the compass test, which that's where they're going to ask you this, for the greatest common factor, the answer is 12, not 6. Okay, what does this reduce to? What did you use? 2. So we reduce by 2, and we'll get a new equivalent fraction of 1 over 8. What about here? What do I reduce by? What factor? 9. And that'll give me 1 over 2. What can I reduce this one by? 11. What's my new equivalent fraction? 1 over 12. What do I reduce this one by? 5. And I get what? 1? 3 over 4. Okay. What do I reduce this one by? If I do 4, it should be 8, right? And then 8 goes in how many times? This is the greatest common factor, you guys. But you could have done 4. You just would have to reduce again by 2. So what would I get here? I'm getting 2 over what? Two goes 1. Yeah, you're right. It is 15. 2 over 15. Now here's some practice questions I'd like you to do. When you guys have a setup and you're missing a number, find out what number they reduced it by. So in this case we had 25 over 40, and the new fraction or equivalent fraction is going to be 8 on the bottom. Well, to go from 40 to 8, I had to divide by 5. Now listen to this rule. What I do to the bottom, I got to do to the top. What I do to the top, I got to do to the bottom. Otherwise, they are not equivalent. You have to use the same number and do the same operation, which in this case is division. So what should the top be? Okay. What do I do here? How did I get from 57 to 19? Hello. What did I just say? Divide by what, sweetie? 3. What I do to the top, I got to do to the bottom. What's missing? How much? 31? 21. Okay. Okay, what's missing here? What did I do?
16.
Divided by 16. So what I do to the top, I do to the bottom. So what's my bottom answer here? 4. Okay. My favorite number. So what happened here? What did we do? How did we get from 169 to 13? Remember, we did squares not too long ago. 13 times 13 is 169. You guys better remember that. 2/13. What I do to the bottom, I got to do to the top. Any questions on equivalent fractions? Any questions on writing the greatest common factor? Any questions on reducing? The next couple of pages in your packet up to page 15 are going to be reducing, writing the greatest common factor, writing out factors like we did here on the board as an example, okay? Now the last thing I want to teach before we go on break time is how to order and compare your fractions. ordering and comparing your fractions, which is going to be the last part of your packet where you're going to be comparing and ordering. Then I also gave you guys like a little activity on page 19, measuring with the ruler that I've already given you there. Now, what are my comparison symbols again? There's 3 of them. Small, bigger. Greater than, less than, and equal to. Don't forget the alligator is eating the bigger one, right? Okay? So what symbol should I have here when I'm comparing 3/8 to 1/8? Less than? You're telling me 3/8 is less than 1/8? Remember, we read from left to right. What symbol should I have here? This is bigger, so you should have a greater than symbol. Okay, which is bigger here? Let's see if they want bigger here. Yeah, which is bigger? 5/8 is bigger. Why is 5/8 bigger? I want you guys to imagine a slice of pizza. If you have a pizza and you slice it into eighths, and then you have a pizza and you slice it into ninths, which slice is bigger? Okay, so since you have the same quantity in your numerator, that means you have 5 slices. 5 slices of the 5/9 is going to be smaller in quantity than 5 slices of the eighths, because the eighths are bigger. So anytime your numerators are the same and your denominators are different, the smaller denominator is bigger. Just think of pizza and you'll be okay. Yes, okay, well, it's almost break time. Y'all can go get some breakfast. Okay, tell me which one of these is bigger. Which be bigger?
5/6.
Okay. Thank goodness y'all got a teacher today. Okay, what's a denominator that those two numbers have in common? What would be the LCM for 6 and 4? 2? No. 12. Twelve is the least common multiple. So when I make these equivalent, the first one would be equivalent to 9/12, and the second one is equivalent to 10/12. So which be bigger? Thank you. Now, all I did was raise the fractions. I found out what the LCM is, which you guys should know how to do now. The LCM for 6 and 4 is 12, because 6 is the largest. When I do multiples, 6 times 2 is 12. 4 goes into 12. Okay? I raised the fractions to 12. 6 times 2 is 12, so 5 times 2 is 10. This is an equivalent fraction for me to compare. 4 times 3 is 12, so 3 times 3 is 9. And I can compare them. Now, how many of you remember doing this in fractions where you just raise the fraction and compare them? Okay? Now, sometimes you don't want to do all that. At least I don't. This is perfectly good math. If this is what you remember how to do, go ahead and do it. Find your LCM, raise your fraction, and then compare the fractions to see which is bigger and which is smaller. Perfectly great technique. But can I teach you a shortcut? I call it the quick and dirty. Can I show you the quick and dirty? Okay. Take the denominator of one and multiply it with the numerator of the other. Answer goes with the numerator. So what's 4 times 5? 20. What's 6 times 3? 18. Which be bigger? 5, 6. Here's my shortcut. Take the bottom of 1, multiply it by the numerator of the other. 5 times 4 is 20. Take the bottom of 1, multiply by the numerator of the other. 3 times 6 is 18. 3/4 is less than 5, 6. Shortcut. Cross multiply. 4 times 5 is 20. The answer goes with the numerator. 6 times 3 is 18. The answer goes with the numerator. 3/4 is less than 5, 6. Quick and dirty, quick and dirty, quick and dirty. Okay, let's try another one here. Which is bigger? Quick and dirty, quick and dirty, quick and dirty. 2 times 1 is 2, and 3 times 1 is 3. Hi. Which is bigger? 3 times 4 is 12. 5 times 2 is 10. Which is bigger? You're not using my quick and dirty now. Come on. Which is bigger? 4 times 7 is 28, and 8 times 3 is 24. Which is bigger? Do I need to worry about the 5s that are whole numbers? Because they're the same number. 3 7s is bigger? 5 times 3 is 15, and 7 times 4 is 28. Hello? Hello? Okay, so when I'm saying hello, that means rethink it, please. Okay, which is bigger? Hello? What's wrong with you guys today? Well, Rebecca, you're the only one that said the right answer. Everybody else was like sitting there like, I don't know. Good, I'm glad. It takes you about an hour and a half, and then you start getting in. Your timing is okay, which is bigger? 4/5. No, what did you say, 3 1/2? 2 times 4 is 8, my darling. 5 times 1 is 5. You guys are scaring me. No, this one is bigger. If I raise this to 10, this would be 5 over 10, and this would be 8 over 10. So this is bigger, okay? Which is bigger? You don't even need to compare these. 4 and 11 twelfths and 7 twelfths. You got the same denominator. Which is bigger? The denominator is the same on that one, so that one's easier. Which is bigger here? All right, now that you guys know how to figure out which is bigger, then you'll be able to order, which is the last thing that we're going to be doing today. Okay? Now, I'm going to order these fractions. And how do they want us to order it? Because you do need to read how they want it ordered. Okay, what's the smallest fraction? Then what? Now, why was that so easy? Because the denominators are the same. Now, let's see how your brain's working now. Bring it on, like Donkey Kong. Let's go. Nope, I wanted an order from largest to smallest. No, what's the largest? Come on now. What's the largest? Thank you. Think of the pizza slices. Okay, come on, y'all. I told you it was on like Donkey Kong. That means pay attention. The smaller the denominator, the larger the slices of pizza. You're going to get 6 of each one, but the biggest one are the ones that just are sliced into 7s. The ones sliced into 11s are really tiny, itty, bitty ones. Okay, cool. You guys are going to have to do this, so y'all better get it together. Order from smallest to largest. Which one's the smallest? Which one is the smallest? You guys, what's 15 times 4? And what's 8 times 9? So which one is smaller? Thank you. Come on. You guys aren't focusing. If you use the quick and dirty, you should be able to get that like that. You almost there. Please wake up. Please wake up if you want your teacher to still have sanity. Okay. Order from smallest to largest. Which one is first? 3 times 7 is 21. Let me put them up here. Maybe you guys can see it. My goodness. Okay. Don't do that because you guys are not responding in the right way here. Okay. Yeah, I need to play some Aretha Franklin. You better think. Okay. That's what I'm going to blast during break time. You better think because y'all ain't thinking right now. I know this is a lot of concepts to do in one day. Okay. Order from, how do they want us to order? Smallest. Oh, you don't want me to do it? Okay. Now, when you have 3 or 4 or 5 fractions, I'm going to do it quick and dirty, or you can raise a fraction to the least common denominator, which is 10 here, and compare them. But I'm going to compare the first 2, keep the small one, and then compare the last 2. So 5 times 1 is 5. 2 times 3 is 6. Which one is smallest?
1/2.
Okay. Then I'm going to take 1/2 and compare it to 9 over 10 because that's the last one. 10 times 1 is 2 times 9 is 18. So which one is the smallest out of all 3? 1/2. So it should be first in my line. Now I'm going to compare the 2 that are left. What is 5 times 9? And 10 times 3. Which one should come next? And then, of course, 9/10 is the last one. Now, there's another way to do that. You could raise all those fractions to 10 and then compare them. I don't care which way you do it. Just put them in the right order. Just complete that study guide. Now, I know when we come back from break, you guys are probably going to want me to do a few problems for you. And that's okay when you get stuck. Just let me know and we'll work them out. Now, don't forget tomorrow is book check. Now, how many of you are behind? Okay, this is what I'm going to do for you, okay? I do want today's assignment done, but you don't have to maybe do the computer work yet. I will make today's assignment due next Thursday, even though it's supposed to be due tomorrow, okay? Everything else we've done prior to that, prime numbers, exponents, division, multiplying, all of those are due tomorrow, okay? So make sure that you are caught up, but fractions will start that due date next week. Are we good? Does that help with the stress for tomorrow?